Hello, future web developer. Have you ever thought about how computer programs remember information or hold on to pieces of data as they execute? This fundamental concept is managed by variables. Imagine variables as labeled containers or named boxes in your computer's memory. Each box has a unique name, and you can store different types of data inside it. Why are they so important? Well, variables allow you to store, retrieve, and manipulate information throughout your code. This means your applications can be dynamic, responding to user input, fetching data, and changing what's displayed. Instead of hard coding every piece of information, you can use variables to make your code flexible and reusable. For instance, if you want to greet a user by name, you'd store their name in a variable rather than writing it out every single time. In JavaScript, you declare variables using keywords like let or const. Let allows you to reassign the variable later, while const creates a constant, meaning its value cannot be changed after initial assignment. Once declared, you assign a value to a variable using the equal sign. For example, let username equals Alice creates a variable named username and stores the string Alice inside it. Understanding how to declare and assign variables is your first step in making your programs truly interactive. Now that we know where to put our data, let's dive into exploring what kind of data we can store inside these powerful containers. All right, so you know how to create a container for data, but here's a crucial point. Not all data is created equal, and understanding its type is absolutely fundamental for writing effective code. Data types classify the kind of value a variable holds, essentially telling the computer how to interpret and interact with that information. In web development, especially with JavaScript, you'll primarily work with several primitive types. These are the basic, indivisible building blocks of data. First up, we have numbers. This type handles all numerical values, whether integers like 42 or decimals like 3.14. You can perform arithmetic operations on them. Next, we have strings. Strings are used for text, anything from a single character to full sentences. You define strings by enclosing the text in quotes, for example, hello world. Then there are booleans. This type represents a truth value, either true or false. Booleans are incredibly important for making decisions in your code, like is the user logged in? Finally, you'll also encounter null and undefined. These are special primitive values that essentially indicate the absence of a value. Undefined means a variable is declared but unassigned, while null is an intentional no-value assignment. Knowing these primitive types helps you perform the right operations. But what if you need to store more complex, grouped information? That's what we'll explore next. Sometimes a single primitive value isn't enough to represent complex information. What if you want to store a collection of details about a person, like name, age, and address, all together? Or perhaps a list of multiple items, like products in a shopping cart? That's where complex data types come into play. They allow you to group related data, providing a structured way to manage more elaborate information. The two most common complex types in JavaScript are objects and arrays. Let's start with objects. Think of an object as a collection of characteristics. It stores data in key value pairs, where each piece of data has a descriptive name or key associated with it. For example, an object representing a user might have keys like name, age, and email, each holding a corresponding value. This makes your data highly organized and easy to access. Then we have arrays. An array is an ordered list of items. Imagine a shopping list or a sequence of numbers. Each item in an array has an index, starting from 0, indicating its position. Arrays are incredibly versatile for storing collections of similar items. Both objects and arrays are built from primitive types, allowing you to create rich, nested data structures. Understanding these complex types is crucial for building robust applications. So now we have our data, and we know its type. The next logical step is to understand how we do things with this data, like performing calculations or making comparisons. This brings us to operators. Programs aren't just about storing data, they're about processing it, performing actions, and making calculations. This is where operators come into play. Operators are special symbols that instruct the computer to perform specific operations on values and variables. Think of them as the verbs of your programming language, telling your data what to do. You're probably familiar with arithmetic operators from basic math. These include the plus sign, minus, asterisk, and forward slash for addition, subtraction, multiplication, and division. They let you perform mathematical calculations on your numerical data. For example, if you have let x equals 10 and let y equals 5, then x plus y would result in 15. Then there are assignment operators. The most common is the equal sign, which assigns a value to a variable, like score equals 100. There are also shorthand operators like plus equals, minus equals, asterisk equals, and forward slash equals. These combine an arithmetic operation with assignment. So score plus equals 10 adds 10 to score and reassigns the new value. These operators are fundamental for any program logic, but operators do much more. They also help us compare values and make decisions in our code, which is what we'll explore next. How do programs make decisions or check if one value is greater than another? That's the job of comparison operators. These symbols compare two values, and the result is always a Boolean, either true or false. Common comparison operators include equals equals, which is equal to, triple equals, which is strictly equal to, greater than, and less than. For instance, 10 greater than 5 evaluates to true. These comparisons are the backbone of conditional statements, allowing your code to branch intelligently. Building on this, we have logical operators. These operators let you combine or modify multiple Boolean conditions for complex decision-making. The main logical operators are AND, which is the double ampersand, OR, which is the double pipeline, and NOT, which is the exclamation point. AND returns true only if both conditions are true. OR returns true if at least one condition is true. And NOT inverts a Boolean value. Operators are fundamental for program logic and control flow, enabling dynamic code. Mastering variables, data types, and operators gives you the foundational tools to store, manage, manipulate, and make decisions with data, essential for powerful web applications. Keep practicing and you'll be coding like a pro.